Very good evening and a warm welcome to everyone. Welcome to the session. My name is Abhishek. So, in today's lecture, we will be dealing with another topic, that is Fisher's LSD, also known as Fisher's least significant difference. So, first of all, let us find out what is post hoc test. In the previous lecture, I hope in the previous lecture everybody have gone through the ANOVA. So, in that lecture, I have already specified what is the post hoc test. So in this lecture we will be starting with the first question, that is what is post hoc test. A post hoc test is used only after we find a statistical significant result and need to determine where our differences truly came from. The term post hoc comes from the Latin word for after the event. There are many different post hoc tests that have been developed, and most of them will give us similar answers. Now, what is LSD? When you run an ANOVA test and get a significant result, that means at least one of the groups tested differs from the other groups. However, you can't tell from the ANOVA test which group differs. In order to address this, Fisher developed the least significant difference test in 1935, which is only used when you reject the null hypothesis as a result of your hypothesis test results. The LSD calculates the smallest significant difference between two means. This enables you to make direct comparisons between two means from two individual groups. Any difference larger than the LSD is considered a significant result. Now let us see what is the definition of Fisher LSD given by Fisher. One-way ANOVA is used to determine whether or not there is a statistical difference between the means of three or more independent groups. The hypotheses used in an ANOVA are as follows. H0, the means are equal for each group. HA, at least one of the means is different from the others. If the p-value from the ANOVA is less than some significance level, like alpha equals 0.05, also known as significant level, we can reject the null hypothesis and conclude that at least one of the group's mean is different from the others. But in order to find out exactly which groups are different from each other, we must conduct a post hoc test. One commonly used post hoc test is Fisher's least significant difference test. To perform this test, we first calculate the following test statistics. The manual calculation of the LSD is given. The formula is given where, so you can refer to it. So we can then compare the mean difference between each group to this test statistic. If the absolute value of the mean difference between two groups is greater than the test statistics, we can declare that there is a statistically significant difference between the group means. Now let's take a live example. Suppose a teacher wants to know whether or not three different studying techniques lead to different exam scores among students. To test this, she randomly assigns 10 students to use each studying technique and record their exam scores. The following table shows the exam scores of each student, in which various three techniques were used. So the teacher performs a one-way ANOVA and get the following result. So in this you can see the average of first technique, second technique, and the third technique, and this is the sum of first technique, second technique, and the third technique. As you know, the every group was assigned 10 students. So these are the 10 students, and after getting the ANOVA test, the degree of freedom was 27 within groups, and the p-value of the significance is the 0.0187. Moving further, since the p-value in the ANOVA table, that is which I showed, this 0.187 is less than 0.05, that is the alpha, we can conclude that not all of the mean exam scores between the three groups are equal. Thus, we can proceed to perform Fisher's least significant difference test to determine which group means are different. Using values from the output of the ANOVA, we can calculate Fisher's test statistics as following. So this after calculating the LSD, you will get this 5.578 as your value. Now moving further, we can then calculate the absolute mean difference between each group. That is technique 1 versus technique 2, you will get 5.8. Technique 1 versus technique 3, you will get 8. Technique 2 versus technique 3, basically we are calculating the difference between absolute difference. The absolute mean difference between technique 1 and technique 1 versus technique 2 and technique 1 versus technique 3 are greater than Fisher's test statistics. Thus we can conclude that these techniques lead to statistically significant different mean exam scores. We can also conclude that there is no significant difference in mean exam scores between technique 2 and technique 3. As you can see, 5.8, 8 and 2.2. The technique 2 versus technique 3 was explained in this particular slide. Moving further, one of the key points, the LSD will only make sense if you have a significant result from ANOVA, that is if you reject the null hypothesis. Therefore, you shouldn't run the test if you do not get a significant result from ANOVA. Now let us see how to calculate Fisher's LSD in SPSS. So considering this question, we took as the live example. So now let me take you to the SPSS. So meanwhile I have already entered the data which I have shown you in the slides. Now for calculating the LSD in SPSS, now first of all you have to go to analyze, then go to compare means, then you will find so many options, then go to one way ANOVA as it is the ANOVA test. Then these data will be like kept here, so you have to take the data into the dependent list, the groups into the factor, then you have to click on post hoc, then you have to click on LSD and you have to click the continue and press OK. So this will be the result which the SPSS will show you, that is difference between group B and C, group A and C and group A and B. So this was all about the video. I hope this video helped you. Thank you, and we'll meet you in the next session. Very